Hey, welcome back everybody. So today we want to look at polar coordinates and polar graphs, and eventually then in 10.5 we'll look at integrating underneath polar curves. So let's dive right into my notes here. 10.4. First we'll have to introduce what the heck polar coordinates are. Polar coordinates. And if you have no clue, you may even want to go back to my trig videos. So that's math 1540, and they're all on my channel site, 6.3/6.4, and there I'll give you a pretty good, well, very good introduction to polar coordinate systems. But basically what we're dealing with is kind of a polar axis, and then there's kind of an opening of the polar axis with another axis called sort of, don't want to put an arrow on that guy, but we'll rotate some distance theta either in the positive direction, so opening in this direction is positive, kind of opening in that direction is negative. And we'll describe this point here anywhere in the plane via this angle theta and the distance of this side here, something they call the terminal side. Okay, so the distance here we'll call r. So this point we can describe with r and theta. Okay, this point right here is we're going to call it the pole, and usually just it's kind of like the origin. Just give the letter O or something like that. This side is the polar axis. Okay, so when you see it, we usually standardize it on the into the XY plane. So we'll put the polar axis on the positive x-axis, and then we kind of have sort of a different looking graph paper. Instead of a bunch of squares, we have these kind of pizza slices. Okay, so let's just put a couple circles in there. And then we have kind of our angular arms to help us travel around this circle, or the plane, if you'd rather. And usually you'll not have to draw out all the radial lines, depending on kind of the situation that you're dealing with. But the way I usually do it is going first pi over 6, and then this would be 2 pi over 6, which is really pi over 3, 3 pi over 6, which is pi over 2, and then 4 pi over 6, which is 2 pi over 3, 5 pi over 6, and then 6 pi over 6 is just pi, and then 7 pi over 6, 8 pi over 6, which is 4 pi over 3. This would be 3 pi over 2, or 9 pi over 6. 10 pi over 6, which is the same as 5 pi over 3. Let's just put 5 pi over 3. And then this is 11 pi over 6. And of course, I just went in the positive direction around the circles, or around the plane. You can also go in the negative direction and kind of work in the same way. So instead of 11 pi over 6, this first one would be negative pi over 6. Okay. Oftentimes people want to label the pi over 4s as well. So you get about 3, basically, like angular measurements in each quadrant. Okay. So 3 pi over 4. 5 pi over 4, 7 pi over 4, and then back to, this will be 0 or 2 pi or 4 pi, however you want to do it. Okay, so we kind of put the polar axis on the positive x-axis, and then if we want to describe some point, this will be the y-axis, we'll use r and theta to do that. So let's just plot a bunch of points here and see how that goes. Okay, so these are all in the form r comma theta. So usually I do theta first and then the r value, and I'll plot these, and running out of colors. I'll just plot them in black. Okay, so 2 comma pi over 3. So first I rotate by pi over 3. That'll be this radial line here. And then you move 2 units out on the circles. So you use the circles like tick marks. Okay, so here's 1, and then here would be 2, and that will be the first point. Let's call that letter A. Okay. What about negative 2 pi over 3? So you rotate the pi over 3, but instead of being on this side of the arm, you're on the other side. So instead of coming out this way, you go out that way. So you'll have negative 1, 2, and that would be B. You could also kind of just rotate there. So there's one weird thing about the polar coordinates is they're not unique. Okay, so you could also write this as 2 comma 4 pi over 3. So first you rotate 4 pi over 3. Here's 1, 2, 3, 4 pi over 3, and then go out 2, 1, 2, and you still get the same place. Okay. Let's try 3, 11 pi over 6. So I rotate 11 pi over 6, that's here, and then you go out 3, 1, 2, 3. Negative 3, 5 pi over 6. So 5 pi over 6 is right here, and then to go negative 3, you go in the other direction, 1, 2, and lo and behold, then this point C and this point D are the same. Okay, so again, the angles are not unique, or the polar coordinates are not unique. Okay. Let's try this one, 2 comma 7 pi over 3. So 1 pi over 3, 2 pi over 3, 1 pi over 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 7 pi over 3, up 2, and you see that one's the same as A. Right. So one thing you could do to get the same coordinate over again, like these two are the same, A and E are the same, all you have to do is add 2 pi to the angle. Okay, so if you took pi over 3 and then added in 2 pi, which is the same as 6 pi over 3, you would end up with 2 comma 7 pi over 3, which is what we got there down here. 2, 7 pi over 3. Another thing you could do is change the sign of the r value and then rotate the angle by pi radians. Okay, so 11 pi over 6, and then subtract or even add. I'll just subtract 6 pi over 6, and we get negative 3 comma 5 pi over 6. And you see the C and D then are the same, just doing that kind of process. So in general, we could kind of make that a rule here. So we have non-unique representations. Non-unique representations. So basically, if you start at r comma theta, one thing we did, what we saw there was to add 2 pi, multiples of 2 pi to theta. The other thing you could do is make the r value negative and then rotate the angle by pi, some multiple of pi. In particular, you want an odd multiple of pi, so it won't work if it's an even multiple of pi. So instead of saying pi n, I got to go something like pi times 2n plus 1 to make sure that all the multiples are odd. Okay. Okay. Converting from polar to rectangular then comes down to just a set of equations that we'll use. You can remember this set if you know your basic trig, coordinate conversion. So here, this picture, I believe, is kind of the key to remembering the formulas. Okay, so we have point in the plane. It could be represented with the coordinate r comma theta or the coordinate x comma y. And then this would be our angle theta, and the distance from this point here to this point here would be r, And then this point down here would be x, and this, not this point, but this distance would be x, and then this distance here would be y. So if you have that picture in mind, you can kind of finagle all of the formulas you need just by doing a little bit of trig and Pythagorean theoreming it. Okay. So first, the Pythagorean theorem tells us right off the bat that r squared is equal to x squared plus y squared. Okay, one formula down like 4 or 5 ago. Trig tells us that the cosine of theta is equal to adjacent over hypotenuse, so x all over r. In other words, we can convert x into polar coordinates using the formula r cosine theta. And we can do the same thing with sine. Sine is opposite over hypotenuse, so y will equal r sine theta. And we do the same thing with tan. The tan formula isn't used as often, so I kind of put it all to itself. Opposite over adjacent. And that turns out to be it pretty much. Those are the formulas we need to kind of get the job done. Okay? Okay. So in the first kind of problems, and we'll just convert a polar coordinate to a rectangular coordinate. So going from polar to rectangular. The book will give you, or the homework problem will give you a polar coordinate like 8 comma pi over 2, and you got to convert it into rectangular. And this version's pretty easy. You just use, x equals r cosine theta. So in this case, r is 8, theta is pi over 2. So 8 times cosine of pi over 2 is 8 times 0, that's 0. So the x-coordinate is 0. And then the y-coordinate will be 8 sine of pi over 2. So that's just going to give you 8. Okay, so no big deal there. And you'll see if you plot it using either the rectangular coordinate system or the polar coordinate system, you kind of get the same thing, right? So sort of using our polar coordinate system, I got to draw like 8 circles, so bear with me. 1, 2, 3, 4, 5, 6. I should have just went by 2s or something. 7, 8. Ugh. Okay. So I rotate by pi over 2. That'll be this line here, and then I go out 8. So that'll be this point here. And of course, in the rectangular coordinate system, it's just 1, 2, 3. Don't move in the x direction, and then go up 8 in the y direction, and of course that's 0, 8. So it's the same in the plane here. Let's look at one more example. I think it's just one more, and then we'll move on to the other version. -4 comma -3 pi over 4. So we could plot it first. So I need like 4 circles, 2, 3, 4. And -3 pi over 4, we're rotating now in this direction. So here's 1 pi over 4, 2 pi over 4, -3 pi over 4. And then you go in the other direction, though, so you actually go out this way, and you're going to end up in the first quadrant. Okay. Okay, anyways, let's get the coordinate. This will be -4 cosine of -3 pi over 4. And y will be -4 sine of -3 pi over 4. I need to figure out the sine of cosine and sine. The reference angle is radical 2 over 2, but I need to figure out what sine is cosine, what sine is sine. So -3 pi over 4, here's -1 pi over 4, 2 pi over 4, 3 pi over 4 is in the third quadrant. So cosine is going to be negative, and sine is going to be negative in that quadrant. So this will be negative times negative is 4 times root 2 over 2. And likewise for this one. It's going to end up with 2 root 2, comma 2 root 2. So that'll give you 2 root 2, comma 2 root 2. Okay. Okay, so in the rectangular coordinate system, you know, you go out 2 root 2 somewhere right here, and then if you go up 2 root 2, you'll get there. And of course, this distance is the 4. Okay. Okay, great. Let's look at the other kind of conversion then, going from a polar coordinate to, rectangular to the polar. And this is where you're going to have to use unfortunately, the tan theta formula, which comes with its own nightmare issues. I lost my formulas there. Okay, we need to use this and this. Basically, the two formulas we didn't really use in the other conversion. So going from rectangular into polar. Because of the non-uniqueness, the book will have to kind of give you a range of solutions that they want. So in the range from 0 to 2 pi, they want to find 2 sets of polar coordinates, not including 2 pi. Find 2 sets of polar chords. Okay. And I won't be asking you to do this kind of operation on a test, but sometimes it will happen that you may have to do it in the homework. So in these cases, I always plot first. I need to see which quadrant I'm in, and so that's what I'll do first. So negative 1, 2, 3, and then 1, 2, 3, 4. Okay, so I'm in the second quadrant. Okay, so there's going to be 2 ordered pairs that work for me in the polar coordinate system. There'll be r comma theta, and then there'll be negative r comma theta plus pi. You know, assuming it's plus or minus pi, you know, depending on where I am in the 4 quadrants. Okay, so first, might as well get the r part out of the way. So r squared is equal to, and this is your x, this is your y. So r squared will be equal to 9 plus 16. So r squared is 25. In other words, r is 5. Okay. Then I need my angles. So to get that, you have to go to your tan theta equation. So tan theta is opposite over Jason. And then you got to go to your calculator. So theta, you're basically taking tan inverse on both sides, and you'll end up with theta is tan inverse of negative 4/3. So let me get that from my calculator. Make sure you're in radian mode. I'm going to make sure I'm in the right mode. And I'm not. You need to be in radians. Okay, so tan inverse of negative 4 over 3 gives me something I can't use. Okay, so negative 0.927, I'll say 3 to 4 decimals. So the problem with this calculator answer is it's not in our appropriate range. Okay? So what I'm going to do first is get the reference angle. And to get the reference angle, all you need to do is kind of rotate the calculator answer here positive. So just reflect that angle about the x-axis. Okay, so you'll get this angle, and that will be sort of your reference angle, 0.9273. Okay. Because the calculator answer is this angle right here, which is kind of useless for us. Okay. Okay, once we get the reference angle, we need to find the angle in the second quadrant, and then we'll also need an angle here in the fourth quadrant, such that both those angles are in between 0 and 2 pi. Okay, so to get our first angle, just call it theta 1, I'm going to take a pi, 180, and subtract away the reference angle. Okay, and I'll go to 4 decimals again. So pi minus my answer, I'm getting 4.0 something, which seems wrong. Oh, I gotta add it. It's stored in a funny way. Sorry, 1 second. So pi minus 0.9273. So we got 2.2143 rounded to 4 decimals. Then for theta 2, you need to take 2 pi and subtract away. And this is stuff you would have learned in trig. Okay? You take 2 pi and subtract away the reference angle. If you needed the angle in quadrant 3, you would take pi and then add in the reference angle. Okay. Okay. So what was this guy then? 2 pi minus 0.9273. And I'm getting 5.533. Wait a second. 5.3559. Okay, so our two answers then will have R, which is 5, comma 2.2143. And then again, if we rotate 90 degrees, or sorry, rotate 180 degrees, negative 5, comma 5.3559 will be the other answer. Okay. Okay, so those are pretty annoying, but thankfully we aren't really called upon to do those very much. What we'll be more interested in will be the polar graphs. Okay, okay, so let's start looking at the polar graphs. And the easiest polar graph is just the graph of a circle. Okay, so for example, if we have R equals 5. What this equation means is that R is 5 and theta is allowed to vary. So think about back in pre-algebra or stuff like that, where you had equations like x is 5. What would that mean? That would mean basically x is always 5, and then y can be anything. Right? So the end picture, you have 5, comma 1, 5, comma 2, 5, comma 3. It's just a vertical line. Okay, so x has to be 5 and y can vary. And it's the same idea here. Basically, you can always do like a table. Usually they do their tables sideways for polar graphs for whatever reason. So you'd have 5 at, whoops, and the R is 5, not theta. So you get 5 and then 0. Just go at like pi over 4 or something. It's 5, pi over 2, 5, 3 pi over 4 gives you 5, 4 pi over 4 pi gives you 5, 5 pi over 4 is 5, 6 pi over 4, which is 3 pi over 2, is 5, and then 7 pi over 4 is 5. It's kind of the most boring graph in the universe, but definitely important because it's used a lot. 2 pi is 5. So you go to your polar graph paper and literally plot those coordinates if you want. Or the way I usually think of it is more of kind of, I have this rotating arm. So there's the positive side and here's the negative side. And it's going around kind of this, it's making a 360 degrees rotation, and as it goes around, the R value is kind of moving up and down on the arm. So the graph, the resulting graph, is created by the rotating motion of this arm, and then the movement on the arm of the R value going up and down. So in this case, though, it's always stuck, right? So it's always stuck out at 5. So 1, 2, 3, 4, 5. Okay, so starting at 0, it's always stuck here, and then theta is allowed to vary. And as it does, as this arm moves, it's basically just like a pen attached to the arm, right? It's just gonna plot out that circle. If you go by the points and you're plotting out those points, I mean, you get the same kind of idea, except you don't get all the in-betweens, right? So if you were to plot out all the points, let's get some pi over 4 radial lines going. So pi over 4, 3 pi over 4 is right here. So if I were to plot those points from the t-table here. 0, 5 is right here. 5 pi over 2, 5 pi over 4 is right here. 5 pi over 2 is right here, etc. Right? You're just going to get these points, and then if you connect them, you get the circle. Okay. Okay. So I was saying it's kind of like when I do actually think in terms of plotting, I'm thinking of this rotating arm, and it's tracing out a graph. Okay. On top of that, you could also consider the rectangular coordinate equation. So if you took this, you could convert it into rectangular coordinates, right? You could say, well, if r is equal to 5, that means r squared is equal to what? Well, r squared would be 25. And then in my formula from above says x squared plus y squared is equal to 25, or r squared if you'd rather, and then just do a substitution, and you get your answer. You get a circle with radius 5. Okay. So anyways, a lot of different ways to kind of do it, but this very important curve here, the circle, r equals whatever. Okay. Okay, let's look at the next kind of set of circles. These are kind of circles kind of not oriented at the center, at 0, 0, so not at the origin. And they look like this. R equals usually some diameter value times cosine theta or sine theta. Okay, so they all have, you could go through and classify all the polar curves as different types. Okay, sometimes it's useful to do that. We don't have as much time as we did in trig, though. So, anyways, to convert this, we can connote x is equal to what? Well, x is equal to r cosine theta. And so subbing in r, the r expression, r is equal to 5 cosine theta. So this would be 5 cosine theta times cosine theta. And so x is equal to 5 cosine squared theta. Y would be r sine theta. So plugging in 5 cosine theta for r, I get 5 cosine theta sine theta. Okay. Okay. For a second, let's think about x squared plus y squared equals r squared, right? So I have x squared plus y squared equals r squared. And in our case, then, that would be 25 cosine squared theta, right? So it's just subbing in r into our given formula, x from Pythagorean formula above, x squared plus y squared is r squared. Okay, and then I can notice something from what I was writing before up top. So you may not necessarily have a direct path for these problems. There's not necessarily going to be an algorithm that we can maybe plug into a computer and the computer can do it for us. There's a bit of ingenuity here. Okay. But anyways, we kind of see this side, the right side, we need to get rid of the theta. We need everything in terms of just x and y. So we have to do something, and it turns out you can kind of rewrite this and see what you need to do. So if you rewrote it as x squared plus y squared, excuse me, equals 5 times 5 cosine squared theta. That's kind of the trick there, right? Because 5 cosine squared is just x. Okay, so we could replace this part, this portion, with just x, and we get x squared plus y squared then is equal to 5x. And that thing, believe it or not, is the equation of a circle. You have to kind of complete the square to make it happen. Blank plus y squared equals blank. So the b over 2a thing, negative 5 over 2, and then square that would be 25 over 4 on both sides. And so you get x minus 5 halves squared plus y squared equals 25 fourths. And so what does that look like as a circle, or in the xy plane? Its center is at 5 halves, comma 0. So you go 1, 2, 3, 4, 5. 5 over 2, 2.5 is right here. Okay. And then its radius is 5/2, so it's going to be a circle kind of oriented in this fashion. Okay, so you're going to have these two forms here. You're going to have, and you don't need to memorize them. It's just, you could, I don't know. R equals a cosine theta, and those will always look like this. And then R equals a sine theta, and those guys will always look like this. Okay. Where A is going to be the diameter. You may think of A as the radius, but it's not. It's actually the diameter. Okay. Okay, so let's do the other version then. So example, R equals, let's just say 2 sine theta. Okay. And this time, instead of doing the rectangular coordinate conversion and getting it into x, y form, I'm going to try to just plot it kind of using brute force. Okay, so you could do a table. You could do your theta comma r table here, and usually you could just go by pi/2s or whatever you fancy. So pi/2, then pi, and then 3 pi/2. And then 2 pi, and then it just repeats itself over and over. But if you plug these values in, you're going to get 2 times sine of 0, that's just 0. Sine of pi/2 is 1, so that'll be 2. Then this will be 0 again, then -2, and then back to 0. Or you could, I prefer actually just graphing the thing. Okay, so 1, 2, 1, 2, 2, 3, 4. And in general, that's what I'll be doing. I'll be graphing it. So at amplitude of 2, and its period is just 2 pi. And you could read all the information you need from this graph. This would actually be the in terms of r and theta, not x and y. Okay. Okay, and then eventually I have to go over to the xy plane and graph it in my polar graph paper. So this is x and this is y. I need to go out to 2. So here's 1, and here's 2. Okay. All right. Then on a graph. Okay, so I start at 0, and then if you just go the pi/2, then it jumps out to here. So you don't really get the full picture with the chart. So you may need some extra values, and you can kind of see, all right, pi/4 is like at 1.5-ish, so it would be like in here. And then it would be less and less as it gets closer to 0. Okay, so as it rotates, it's kind of tracing out something that looks like this. I missed my point there. Going from 0 to pi, and then it'll start going in the reverse direction. All your values will go negative. Okay. So as you go from pi/2 back to pi, it'll go down back to 0. Okay. And then it'll repeat itself. Okay. So from 0 to pi/2, we got this part being traced out. Okay. And then from pi/2 to pi, it traced out this part. Okay. And you're on your kind of radial line thingamajig. Let's put it in yellow, I guess. You're sitting, well, that's not yellow. You're kind of sitting right here. And then as it rotates down from there, the values become negative. Okay, so let me maybe put a couple extra radial lines in here. So up here, it was still positive, and it would have been like right here on that graph. And then as it goes to 0, the points go back to 0. So you would be like right here. And then as the line tilts down in this direction, in other words, as it goes towards pi over 3 pi over 2 down here, you're going to go on the other side of the arm. So the points start going negative, basically. And then you would be right here, and you would be right here. And what it's doing, it's tracing itself out again. And one thing that's important for us is going to be knowing where the entire graph is traced out from, because we'll need to know that for integration. Okay, so this entire graph was traced going from 0 to actually just pi. Okay, and you see you get the other orientation as opposed to the kind of sideways. Now you're getting the up and down orientation. Okay, let's try, let me maybe show you an animation. Hopefully that will kind of maybe clear it up a little bit. Usually I have this, it's in Wolfram. I don't have access to Wolfram right now though, so I have to use this other guy's video. And he kind of shows you how that arm is rotating and at the same time tracing out. Okay. Let's see if he shows maybe the one we were working on. No, he's not going to show it. Great. Sorry, just one. There it is. So this is the cosine version. So let's see. Okay, so you kind of see as the arm is rotating, and now the positive side of the arm is here and the negative is here. So it's starting to go negative and on the negative side of the arm, and then as it rotates, it should rotate back around to a circle as it goes towards pi over 2. Okay, so this was a cosine, r equals cosine theta. And then it's going to repeat itself as it goes from pi to 3 pi over 2. Okay, let me sort of fast forward ahead. We want to do one of these next. This is going to be a rose curve, some sort of rose petal. So usually you can see these, it'll be like sine of n theta or cosine of n theta. And depending on whether it's sine or cosine or the n value, it tells you how many petals there are on your rose. So you can see he's at pi over 2, and now he's going to pi. He's on the negative side of the arm, so it's tracing out in this direction. And he's going to go to pi next, and it's going to probably trace back around to 0. Yeah. And then he'll go from pi to like 3 pi over 2. And it's going positive and tracing out this way. And then it's tracing out, going back to 0 at 3 pi over 2. And then it's going to go negative on the arm as we go to 2 pi. Okay, and sure enough, it goes all the way around. And be aware of how far it takes you to trace out the entire curve. Okay, so let me get back to my work then. And let's look at one of these rose petal things. Okay, so this will be the video quiz question as well. Okay, so this is our video quiz. R equals 2 cosine of 3 theta over 2. We want to plot this guy. It'll be a rose petal of some sort. Generally, when I plot trig functions, I go through and get the amplitude first. The amplitude here is the absolute value of whatever is in front of the cosine function or sine function. In this case, it's just 2. Then I'll get the phase shift and the period. There is no phase shift here. The period, to figure that out, you just take whatever's inside the cosine function and wedge it in between 0 and 2 pi. So you got 3 theta over 2, wedge it in between 0 and 2 pi, and then solve for theta. Okay, so multiply all 3 sides by 2/3. You get 2/3 times 2 pi over, well, 2 pi. So the period then will be 4 pi over 3. In general, you just take the endpoints of this interval, 4 pi over 3, and subtract the beginning. In this case, it's just 0, so your answer for the period would be 4 pi over 3. And then thirdly, I kind of figure out my tick marks for the plot. And what you're doing for the tick marks is just dividing the period by 4. So in this case, 4 pi over 3 divided by 4 would be the same as multiplying by 1/4, so we're going by pi over 3s in our graph. So in the r theta plane, again, you could do a t-table if you want. I'm just going to do a graph of the, I'm going to go by pi over 3s. But you got to be able to do these by hand, because when we do integration, you got to know where to start and where to begin, where to end. Okay, so you got to know how to do it by hand. So this would be 5 pi over 3, 6, 7, 8, 9, 10, 11, 12-ish. You don't know how far we'll need to go, but 2, amplitude is 2. It's a cosine, so it starts up at 2 and then goes to 0. And goes back like this. Okay, so then I'm going to go to my xy plane and plot this stuff. So this is currently the r theta plane. But I just need 2 circles this time. And then I'm going by pi over 3s, so I'm going to let my angles in my xy plane here also be pi over 3s. So here's pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5, 6, 7. Whoops, did I miss one? 1, 2, 3, 4, 5, 6 pi over 3, which is really 2 pi, or 0. Okay. All right, so this is pi over 2, 3 pi over 2, if you wish. Okay, and then we need to plot this guy out. So I'll start in blue, going from 0 to pi over 3. Okay, just that little portion there. And what's happening is I'm starting at 2, and then it's decreasing to 0. And as it rotates, it kind of creates that circular kind of petal shape. Whoop. Okay, so that's the first part. Then I'll do the next part in yellow, going from pi over 3 to 2 pi over 3. Okay. So from pi over 3 to 2 pi over 3, I go negative. So instead of being kind of in this region, I'm now really actually in this other region because it's negative. Okay. So as I go from 2 pi over 3 to pi over 3 to 2 pi over 3, it's going from 0 to negative 2. Okay, so 0 to negative 2. That'll be about right there. And then for the next, let's go back to blue. So it'll go from negative 2 back to 0. And we're going from 2 pi over 3 to 3 pi over 3. It's kind of in this kind of sector. Okay. So 2 pi over 3 to 3 pi over 3 will look like that. Okay. And then we'll go back to yellow. Going from 3 pi over 3 to 4 pi over 3, and we're back on the positive side, so 3 pi over 3 to 4 pi over 3 is this sector, and I'm back positive. So it probably should look like this somewhat. Probably making my petals too big, but there they are. And then I just start repeating. So I go back to blue, and it's going from where are we? So 4 pi over 3, the 5 pi over 3 is this sector. And it's going from 2 to 0. Okay, so 2 to 0 in there. And then 5 pi over 3 to 6 pi over 3, I'm on the negative side. And I'm on yellow. 5 pi over 3 to 6 pi over 3, I'm actually over here. So that will go back like this. Okay. And then 6 to 7, 6 pi over 3 is really just pi over 2, 6 to 7 is in this quadrant. Okay, and it will increase back to 0, like that. And then 7 to 8. 7 to 8 is this sector. And it's going from 0 to positive 2, so it's increasing back out like this. And then from 7, 8 to 9, it'll decrease back to 0. So we're back kind of to the start of our curve, the sine curve part, and the r theta plane. But anyways, I'm going from 2 back to 0, like that. And then from 9 to 10 pi over 3, 9 to 10, I'm going negative. Okay, so where the heck is 9 to 10? So 5 pi over 3, 6, 7, 8, 9 to 10. Okay, so I'm kind of in this region, but I'm negative now, and it'll that's not, where am I? Kind of lost as to where I am. So I think it was 8 to 9. Okay, I should have 5, 6, 7 pi over 3, 8 pi over 3. Is that correct? 1, 2, 3, 4, 5, 6, 7, 8. And this is 9 pi over 3. And then this is the 10 pi over 3. That's where we are. I thought. Yeah, so 9 to 10 pi over 3, I'm going negative, so I'm shooting out in this direction. And then from 10 to 11, whoops, this would be 11 pi over 3. That will be right here. So you can see 10 here and 11. I'm going back to 0 right here. And then I'm going from 11 to 12 pi over 3. This final section, I should be going back from 0 to 2. Okay, and that would be right here, because I'm going from 11 to 12. Okay, so that would be right here, and that completes the entire rose petal. So it's traced out from 0 to 2 pi. Okay, and that's the video quiz. You're going to draw that out for me. Okay. You know, if you need more practice, you can always look at my trig videos and do more of them. I'll look at, you know, as we go through, I'm going to have to draw some more, so this won't be the last one I draw for us here today. Anyways, the next section we want to look at is finding kind of the tangent lines, the slope of the tangent lines to these things. In other words, working with the derivative of these polar equations. Okay. And the easy way to get it is to just think in terms of these guys as being kind of parametric equations. Tangent lines. Okay. So note our x formula is r cosine theta, and then our y formula is r sine theta. So to get the derivative equation, basically all I have to do is the ratio of the derivative of y with the derivative of x with respect to theta. R is generally considered a function of theta, so in the book you'll see it written as f of theta comma cosine theta times cosine theta, and then y is f of theta cosine sine theta. Okay. And then for the derivatives, you just take the derivative of y with respect to theta and put it all over the derivative of x with respect to theta. And then if you need horizontal and vertical tangents, like you probably will, for the vertical tangents, That's where the dx with respect to d theta is 0, but the dy with respect to d theta is not 0, and then the horizontal tangents are going to be the places, I'm just abbreviating it, tans for tangents, sorry, tangents. That'll be where dy over d theta is equal to 0, but dx over d theta is not equal to 0, just like with the parametric equations. Okay, so let's play around with one of these. Take a look. An example. Find the horizontal and vertical tangents. So I'll abbreviate horizontal as hori, and then vertical as verti. And the graph we want to work with is r equals 2 times 1 minus cosine theta. And this is one of our snail equations. This one is a cardioid, so it kind of looks like a heart, but we kind of group them all in as snails. Limnaceates is the French word for snails, and you'll see that word in the book. Okay, but it's a snail. All right, so to graph this thing, I'm going to kind of distribute the two. So first, I note the amplitude is just the absolute value of -2, which is 2. Secondly, then the period, there's no phase shift. If there was a phase shift, you would see something inside the theta, and I don't think there are any phase shift problems in the book. So just the period is the traditional version. It's wedged in between 0 and 2 pi. So you can make your tick marks 2 pi over 4. So in other words, we're going on pi over 2s. One thing to note here, there is a vertical shift because of this value 2 here. It's going to be going up by 2. And then on top of that, there was this negative right here in front of the 2 cosine theta. What will that do? That will do a rotation. Okay, so this is like step 4. There is a vertical shift, but you have to rotate before you can get the vertical shift. So step maybe 3a, there's a x-axis rotation. Okay, so let's go ahead and plot the guy, see what it looks like in the r theta plane. Okay, so 1 by pi over 2s. Amplitude originally is 2. I'm probably going to need a little more space then. Okay, so originally, it kind of looks like this. And then the x-axis rotation will make it look like this. And then shifting it up by 2 will kind of give us a new center of study. Let's turn it, let's use blue. So moving all of these points up 2 places. 2, 2. Let's move that point up too. I should put them in different colors or something. It's these red points. I'm moving all of these up by 2. Okay. This guy is up by 2. This guy is up by 2, and you end up with this graph. Okay. Okay. So this, in case we need some extras. What are these? Pi over 2. 2 pi over 2, 3 pi over 2, 4 pi over 2. Okay. And we'll go to my xy plane. Looks like I need 4 circle thingamajigs. 2, 3, 4. There's probably not enough room to get a good idea what it looks like, so let's try that again. Okay, so I'll plot my points in red, starting with 0, 0. So it's going 0 and then pi over 2. As it rotates, it's increasing, so you're going to get kind of almost a pedal type look to it, but it's more circular than pedalish. So it's going to increase, 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 and then level off at 2. And then, level off at, it only goes from 0 to 2 on the, and of course I just erased my entire graph. And that first, from 0 to pi over 2, it's just increasing the 0 to 2. Okay. So I edit that. So it's just increasing like that. Okay, 0 to 2. And then, so where am I on the graph? I've gone from here to here. And then it's going to keep increasing and then level off at 4. Okay, so it's going to keep increasing, but level off at 4. Okay, and then it's just going to have the reverse behavior. So it's going to go back to 2. And there's symmetry involved. Okay? And we don't have time to talk about symmetry. You probably talked about that more in trig. Okay? And then it's going to end up back at 0. So it's being traced out from 0 to 2 pi. You can visually inspect it and kind of see where all the different kinds of horizontal and vertical tangents are. So there's kind of a vertical one here, vertical one, and then a third vertical. And then there'll probably be some horizontal ones in here somewhere. Okay. And then a non-smooth point. So the dx with respect to theta and dy with respect to theta will both be 0 at 0. Okay, so anyways, let's dive in here then and get those points kind of analytically. What we need to do is set the derivative of y with respect to theta equal to 0, and the derivative of x with respect to theta equal to 0. Okay, so let's get those formulas. Our original formula R is so the original formula is 2 minus 2 cosine theta. So you can't work with this to get the derivative. You have to get that x and y formulas, or the parametric forms. So remember, x is r cosine theta. So x will become then, when I do my sub, so I need the sub r, this thing junk in here. And I get 2 minus 2 cosine theta times cosine theta. And that will give me 2 cosine theta minus 2 cosine squared theta. And that's the thing you take the derivative of, okay, and set it equal to 0. And let me also at the same time kind of get the y formula. Y is r sine theta. So y will be 2 minus 2 cosine theta times sine theta. And then our formula for taking, we need the derivative, so it would be 2 sine theta minus 2 sine theta cosine theta. Okay. Okay, so first get the derivative, so x prime will be negative 2 sine theta minus power rule, bring down the 2, you get 4 cosine theta, then chain rule times the derivative of cosine, which is negative sine. Clean that up and set it equal to 0. Okay. You can factor negative 2 sine theta out, and you get 1 minus 2 cosine theta. And we're setting these parts equal to 0, so you get negative 2 sine theta equal to 0. In other words, sine theta equals 0. And where does that happen? It happens when theta is 0 or pi. So when theta is 0 plus pi n, in other words, just pi n. The other guy, let's take a look at the other guy. Do I have something? No. On the other one, we're looking at 1 minus 2 cosine theta, so equals 0. So 2 cosine theta equals to 1. Cosine theta is 1/2. And in the unit circle, the reference angle for that is pi over 3. So theta is pi over 3. The other angle, and between 0 and 2 pi will be, where cosine is positive, will be 1, 2, 3, 4, 5 pi over 3. And then, of course, you can add in multiples of 2 pi. Those are all the solutions. We really only need the solutions in between 0 and 2 pi. Anyways, let's look at the other guy and kind of solve that thing. Okay. So getting the derivative, y prime is going to be 2 cosine theta minus 2, and then I need a product rule for this one. So sine theta times the derivative of cosine is negative sine theta, plus the derivative of sine is cosine theta times, leave cosine theta alone. Okay, so I'll set that equal to 0. I have 2 cosine theta, distributing the negative 2 plus 2 sine squared theta minus 2 cosine squared theta. For these, you want to get everything in terms of cosine or sine with everybody with the same angle. So what I'm going to do is rewrite this part with the Pythagorean identity. So I got 0 is 2 cosine theta plus 2 times 1 minus cosine squared theta, because we recall if sine squared plus cosine squared is equal to 1, then sine squared is equal to 1 minus cosine squared theta. Okay, minus 2 cosine squared theta. Distribute that 2. I get 0 is 2 cosine theta plus 2 minus 2 cosine squared theta minus 2 cosine squared theta. I can put those together and move it to the other side. So you'd have 4 cosine squared theta. Move this to the other side, minus 2 cosine theta. Move that to the other side, minus 2 is 0. I need to solve this. So it has a quadratic form, so you just factor it. Looks like it's going to be, we could factor out a 4 before we do any, or a 2. So it would be cosine squared theta, 2 cosine squared theta minus cosine theta minus 1. So let's just rewrite it like that, equals 0. And then this will be 2 cosine theta and just cosine theta, and then plus and minus, or minus plus. These both have to be 1s. We want the bigger one to be negative, so minus there, and then plus here. And then you set each part equal to 0. So 2 cosine theta plus 1 is 0, and then cosine theta minus 1 is 0. So 2 cosine theta equals negative 1. So cosine theta is negative 1/2, or cosine theta equals positive 1. Okay. So again, we're kind of just looking for solutions. I shouldn't have gone crazy and give you the infinite solutions, but here we have we just need the solutions in between 0 and 2 pi. Okay, all the other ones will just give you repeat positions of where the asymptotes are. So if you find 1 is equal to, in this case, that guy right there is going to be the 2 pi over 3, I think. That would be the one solution between 0 and 2 pi, but there's obviously another solution. If you just add 2 pi to that, you would get 8 pi over 3 as another one. But it just gives you the same location in the xy coordinate system. Ultimately, we just want the xy coordinates of the horizontal and vertical asymptotes, so you need not worry about the plus 2 pi n portions here. You don't really need that stuff. Okay, that's just going to give you repeats. And the same for over here. The two solutions in between 0 and pi are just going to be 0 and then pi. Okay. So right now we have 0 pi, pi over 3, and then 5 pi over 3. And these are giving you indications of where the vertical asymptotes were, because we're looking for where the derivative of x was 0. So these are kind of vertical possibilities. Over here, you're thinking horizontal possibilities, and let's think of the unit circle in between 0 and 2 pi. Where is cosine negative 1/2? Well, that's going to happen when when the angle's in the second or third quadrant, and the reference angle that gives you 1/2 would be pi over 3. So we're looking at theta equals 2 pi over 3 or 4 pi over 3. And those are exactly where we have these horizontal asymptotes here and here. Okay. The other point that we're getting as a solution is where it's not smooth, right? So that would be where theta is equal to 0. And you see from our solutions, so these are the horizontal possibilities because that's where the derivative of y was equal to 0. You see from your solutions that you have theta equals 0 and theta equals 0 over here. That's where it's not smooth. That's where you get that kink. Okay. You can look at that individual point individually and kind of figure out the ratio of the two derivatives. It's a 0 over 0 case, but you'll probably be able to take that limit using L'Hopital's. Anyways, let's just focus on what we have here. For the vertical asymptotes, it's looking at, we have 3. And if you look at the picture, that kind of confirms it, right? So you go back to the picture, you have these 1, 2, and then 3 verticals. Okay, so we should be able to use those angles kind of mixed with our formulas for x and y in order to get the vertical positions. So our x formula, again, I've already forgotten the x formula was r is 2 minus 2 cosine theta times cosine theta. And then let's get the y formula as well. So that would be 2 minus 2 cosine theta times sine theta. So our vertical asymptotes are going to be at x equals 2 minus 2 times cosine of pi times cosine of pi. Cosine of pi is -1, so it's 2 minus 2 times -1 times -1, which will be 2 plus 2, which is 4, times -1 is -4. And then the y coordinate, when you plug in pi, you get 2 minus 2 cosine of pi times sine of pi. Sine of pi is just 0, so that will just be 0. So we should get -4, 0. And yeah, if you look at the picture, that's one of the verticals. The other two verticals then are going to be at pi over 3 and 5 pi over 3. So this was theta equals pi over 3. Get x equals 2 minus 2 times cosine of pi over 3 is, of course, 1/2. And then cosine of pi over 3 is 1/2. So this will be 2 minus 1, which is 1, times 1/2 is 1/2. And then the y coordinate, 2 minus 2 times 1/2 is 1, times sine of pi over 3 is root 3 over 2. So that'll be just root 3 over 2. And then when theta is 5 pi over 3, kind of get the same thing almost, right? So the x coordinate, oh, that's the difference. So the x coordinate would be, well, let me think. This would be 2 minus cosine of 5 pi. Is it 5 pi over 3 or is it 4 pi over 3? It's 5 pi over 3. So I guess it's negative. So that would be 2 times cosine of 5 pi over 3 is -1/2, and then times -1/2. So that would be 2 plus 2 is 4, times -1/2 is -2. And then the y coordinate, which totally doesn't seem right. What did I do wrong? Maybe they only want the r theta coordinates. Well, okay, so let me figure this out anyways. This will be 2 minus 2 times negative 1/2 times sine of 5 pi over 3. Which quadrant is that? This is 3 pi over 3, 4 pi over 3, 5 pi over 3. Actually, cosine is positive in that quadrant. Sorry. So this will be positive, positive. That will just go back to 1/2 then. 2 minus 1 is 1 times 1/2 is 1/2. And then this guy, sine is negative though, so negative root 3 over 2. So this will be positive in here, so negative root 3 over 2. Ultimately, I think that maybe they asked for the r theta coordinates though. I'm giving you all the xy coordinates. Anyways, 1/2, that seems to kind of match up. Positive 1/2, then root 3 over 2, and then 1/2 negative root 3 over 2 for those two. If they want the r theta coordinates, then it's just a matter of plopping things into your r formula. So that would be 2 minus 2 cosine theta. So for the first one, it would be 2 minus 2 times cosine of pi. Cosine of pi is negative 1, and then you get 2 plus 2. So that would be 4 comma pi in the r theta coordinate system. The next one would be pi over 3, and that would be 2 minus, it would just be 1. And then this one would also be 1. Okay. Let's get the horizontal tangents then. The hori tangents. So we got 1 at 2 pi over 3. And again, if you just need the coordinate r theta, you're using this formula to get the first coordinate there. So 2, the thing that goes in there would be 2 minus 2 times cosine of 2 pi over 3. Cosine is negative in that quadrant, so it would be 2 minus 2 times negative 1/2. So that would be 4. And then we would need the xy coordinate there. Actually, it's not 4, is it? It's 3. This would be, let's not have 2 pi over 3. 1 pi over 3. 2 pi over 3. What the heck am I doing wrong then? Oh, this is negative 1/2, so this would be 2 minus 2 times negative 1/2, which would be 2 plus 1, which is 3. So this is 3. And then let's get the xy coordinates if that's what you need. So x is 2 minus 2 cosine of 2 pi over 3. Times the cosine of 2 pi over 3. So that would be 2 minus 2 times negative 1/2 times negative 1/2, which would be 2 plus 1 times negative 1/2, which would be 3 times negative 1/2 is negative 3/2. And then the y coordinate would be 2, well, just that same thing, right? So it would be 3, and then times the sine of 2 pi over 3. And sine is positive in that quadrant, so that would be 3 times radical 3 over 2. Then when theta is 5 pi over 3, oops, that's not 5 pi over 3, it's the other one is 4 pi over 3. 4 pi over 3. For the r theta version, you need the formula r is the 2 minus 2 cosine theta. At 4 pi over 3, so it's 4 pi over 3, cosine is definitely negative, so it would be 2 minus 2 times negative 1/2, which is 2 plus 1, which is equal to 3. So our r theta coordinate would be 3 comma 4 pi over 3. if you need the xy coordinate, it's x equals, then that would be 3 times cosine of 4 pi over 3. So again, that's negative 1/2, so that would be negative 3/2. And then the y coordinate would be 3 times the sine of 4 pi over 3. In that case, sine is also negative in that case, so it would be negative 3 root 3 over 2, depending on which answer the software wants. Let's confirm that sort of with the graph. So yeah, negative x values and then positive. Okay, so that's really as hairy as it gets, in my opinion. So I think we will, let me think here. Yeah, so it looks like they just want the r theta coordinates. I'm so sorry. That was a nightmare going through all the xy coordinates in the homework. I see some snail figures, so you'll have to be able to draw a snail. Maybe I should draw a snail for us before I leave. One of these ones with the let's do this problem. Okay. Okay, so let's get that. Find the slopes of the tangent line shown below. So giving us r equals 2 plus 3 sine theta. So first off, the amplitude is 3. Secondly, the period. There's no phase shift here. There's really no change in the period. It's just going to go from 0 to 2 pi. The period's 2 pi. The tick marks, you can go by pi over 2's. You just take 2 pi divided by 4. So you're going by pi over 2's. And then note there is a vertical shift, shift up 2. And so in the r theta plane, or the theta r plane, if you want to think of it, I guess, amplitude 1, 2, 3, but then we need some more space, right? So I should probably edit that. Okay, so 1, 2, 3, 4, 5, 6, whatever. So originally the sine curve, going by pi over 2's, is going to look like this. Amplitude of 3. Okay, and then it's getting shifted up 2 places, so its new kind of origin will be here, and you can always think of it as shifting up just points. So this point, this point, this point, and this point up by 2. So we put it in blue. 1, 2, 1, 2. And of course, this other point, I forgot to put the red thing. Whoops, oh, I didn't. 1, 2, 1, 2, 1, 2. Okay, so our new graph looks like this. Okay, and is it really? No, I don't think that's quite the picture, right? I went a little bit too much. So that's the issue, and that's why the graph is going to look weird. Let me see if it'll let me. Yeah. Okay, so the third point there, I've shifted all the other points correctly up by 2. It's this third point. I shifted too far. It should actually be right there. Okay. So there's going to be some weirdness in that one little region from here to here. It's going to be on the negative side of your arm that's rotating around. Okay, so let's see if we can pull this off, get the plot of it, and then answer the questions. Okay, so it's going 1, 2, 3, 4, 5. 2, 3, 4, 5. Okay. It's starting out at 0, 2. So 0, 1, 2. It's starting right here. And then it's increasing to pi over 2. It'll be at 1, 2, 3, 4, 5. Okay, 5. So we'll increase all the way up to 5. Right here. Okay. So that's the first part. And then it'll just decrease back to 0 to 2, which is kind of like 0 in this case. So it's going to decrease back to 2. and then this is where it becomes weird, right? So it's going to keep decreasing until it hits 0, and then it'll go on the negative side of the arm. Okay, so there's going to be some angle in here where it's going to go to 0. So it'll decrease, decrease, decrease into 0, and then there's some angle in there. So maybe put the angle kind of in blue, such that it's gonna go not on this side. It's going to start graphing on the other side of the arm. So you're going to see your picture kind of have this middle loop, and that's kind of the head of the snail. Okay, and it'll go to, I went too far, it should only go to -1. Okay, so you have to graph the head of the snail. Okay, so it goes to -1, and that'll be right here. And then it'll go back to 0. So you see that little head of the snail that I just drew, and then it'll pop back up there for the rest of it. Okay, so that the head of the snail is just this part of the graph from here to here, and that's this little loop here. Okay. So anyways, let's see what they have for us question-wise on this problem. Find the slopes of the tangent lines at the following points. So first they need literally the dy over dx formula. And we might as well find what is x and what is y. So remember, x is r cosine theta. The r expression is 2 plus 3 sine theta. So this would be 2 plus 3 sine theta times cosine theta. And then the y expression is r sine theta. So 2 plus 3 sine theta times sine theta. Okay. So I distribute. So I got x is 2 cosine theta plus 3 sine theta cosine theta. And then I need its derivative. So its derivative is going to be -2 sine theta plus 3. And then I need a product rule. Leave sine alone, the derivative of cosine is negative sine, and then plus the derivative of sine is cosine, and then leave cosine alone, and you end up with -2 sine theta minus 3 sine squared theta plus 3 cosine squared theta. The other guy then, y is 2 sine theta plus 3 sine squared theta, and really avoid trying to use too many of your old trig identities here. For example, you can't do a trig identity on this one. Negative sine squared plus cosine squared is not equal to 1. It's only when they're both positive. Okay, so anyways, this thing, the derivative y prime, will be 2 cosine theta, and then you got to do a power rule on the second term. So that'd be 6 sine theta times the derivative of sine is cosine theta. Okay. So the derivative formula that we're using here to find our, I guess, what do we want to find? Find the slopes. In order to find the slopes, we have to use this derivative formula. And the derivative formula is equal to 2 cosine theta plus 6 sine theta cosine theta all over -2 sine theta minus 3 sine squared theta plus 3 cosine squared theta. And for the slopes, you don't need the r values, you just need the theta. So we need, the first one is 3 pi over 2. Okay, so our derivative, dy over dx, you can notate it like this. That will equal, cosine of 3 pi over 2 is just 0. So it looks like the numerator is 0. And then the denominator will have -2 times sine of 3 pi over 2 is -1. And then minus 3 times -1 squared is +1, and then plus 3 times 0. So basically you're going to get 0 all over -1, which is 0. Okay, so the first guy is 0. Yeah. The second guy at pi. So derivative of y with respect to x when theta is pi. So in the numerator, cosine of pi is -1. So I get 2 times -1. Sine of pi is just 0 though, so you get plus 0. In the denominator, 0 minus 0 plus 3 times -1 squared is just 3. So you get -2/3. The last one, they want pi over 6. That will be a lot more work. 2 cosine. So cosine of pi over 6 is radical 3 over 2. And then plus 6 times the sine is 1/2. Cosine is radical 3 over 2. All over -2 sine. 2 times the sine of that is 1/2. And then minus 3 sine squared. Minus 3 times 1/2 squared. And then plus 3 cosine squared. Plus 3 cosine is √3 over 2 squared. That monstrous looking thing. So we're getting 2 √3s over 2 plus 3 √3s over 2 all over. This will be -1 minus 3/4 plus radical 3 squared is 3, so 3 times 3 is 9 all over 4. So let's look at 5 √3s over 2 all over -4/4 minus 3/4 is -7/4 plus 9/4 is 2/4. And then that'll be 5 √3 all over 2 times the reciprocal. This 2/4 is 1/2, and the reciprocal of 1/2 is just 2. So that would be 5 √3. Let's make sure that's right. Yep. Okay, so that's the idea. This is the same kind of problem, different kind of figure. And then horizontal tangents, and then just some plotting. 3 sine theta should be a circle, so it's nothing weird. Plotting, snail. R equals 3, that's actually, when you have r equals 3 theta, what's happening is the r value is increasing with theta. So you should get something that's like starts at 0 and then just gets bigger and bigger and bigger. So it should be kind of a spiral. So it's like this one or this one, because you have to do it in reverse as well. So negative theta. So if you do it as negative theta, it's going to start going like that and then kind of spiral out like that. So you'll get either B, this one or this one. You can tell probably by the tick marks. So so r equals 3 theta. Yeah. So pi over 2, it should be 3 pi over 2. At pi, it should be 3 pi, so it would be like 6 something. So it would be out here. It'd be out here somewhere. It must be this guy, is what I'm thinking. So again, at 0, it's 0. At pi over 2, it'll increase to like 1.5-ish. Not even 3. It'll be at 3 pi over 2. So usually you just convert things. So you could do like a table of values if worse comes to worse. So theta and r is equal to 3 theta. So 0 will give you 0. Pi over 2 will give you 3 pi over 2. And of course, pi is 3.14, right? So this, I mean, you can literally put it in your calculator and figure it out. 3 pi over 2 is 4.7-ish. And then pi, you know, it's like 3 times pi is 9.42-ish. So on your graph, it's starting at 0, and then it's like at 4. So it starts out at 0, and then goes to 4, and then it goes way out to 9, and then it's going to go way out even farther. So let's see which one it is. It's going to be this guy. Okay. This one, it doesn't go out far enough on that pi over, that just pi. It doesn't go out far enough, so it has, yeah, it is keyed. Okay, and then more graphing. Okay, so hopefully that's good enough, and I'll get you through. Thank you for watching, and we'll see you next time. Sorry this video was a little long.